Good morning, everyone. I'm Kishan Shinde, pursuing my engineering from Sri Venkateshwara College of Engineering in the domain of computer science engineering with artificial intelligence. Today's topic is decision tree algorithm. Decision tree algorithm. So the definition of decision tree is is that it takes an input of an object or a situation described by a set of properties and outputs. It is yes or no decision. Decision tree induction is one of the simplest and yet most successful forms of machine learning. We first describe the representation, the hypothesis space, and then show how to learn a good hypothesis. Each node set tests the value of an attribute. Branches from the node correspond to possible values of the attribute. Leaf node supplies the value to be returned if the leaf is reached. This is one of the widely used and practically methods of induction reference, where examples are generalized and made into a model instantized for another case prediction. This is a simple example where decision tree is being used. Decision whether to wait for a table at a restaurant. Alternate where whether there is a suitable alternate restaurant. Bar whether the restaurant has a bar for waiting customers. Friday as Saturday. Proof on Friday and Saturday. Hungry. Whether we are hungry. Patrons. How many people are in it? None. Some full. Price. The restaurant's rating. Raining. Whether it is raining outside. Reservations. Whether me wait reservation. Type. The kind of restaurant. Indian, Chinese, Thai food, etc. Wait estimate 10 minutes, 10 minutes, 30 minutes, 60 minutes or greater than 60 minutes. So this is a decision where these many attributes have been taken and there is an alternative or decision to be made for a table at a restaurant. This is a small example where decision tree is being plotted. Patterns where none, some, one. So if there is none, then it's no. If there is some, then it is called yes. If there is full, then it is again divided into weight estimate. If it is greater than 60 minutes, then no. If it is from 30 to 60 minutes, then we see alternative. If it's from 10 to 30 minutes, then if we are hungry, it depends on the hunger. It is 0 to 10 minutes, then wait estimate. We will wait. So let's check for 30 to 60 minutes. We'll check for alternate. So reservation of Friday or Saturday. So if there is no reservations, if reservations are not there, then if reservations are not there, then there should be a bar to wait for a customers. If there is no bar, then we will not take that restaurant. If there is a bar, we might take that restaurant. If there is a reservation, then we might take that restaurant. If it's Friday or Saturday, then no. If it's Saturday, then yes. So if we are hunger, then yes. If we are not hunger, we'll wait for the restaurant. If we are hunger, then we'll see an alternative. So we check whether it is raining. If it is raining, then we don't see an alternative. If it is raining, we see an alternative. So this is an example where decision tree has to make a decision at each and every step where the decision depends on the model we make. So this is a basic decision tree learning algorithm where function DTL examples attributes and default returns a decision tree. If examples is empty, then return default. Else if all examples have the same classification, then return the classification. Else if attribute is empty, then return MODE example. Else best choice choose attribute and example. A new decision tree with root test best. For each value vi of best do examples elements of examples with best vi. Subtree, DTL, that is decision tree learning. Examples, attributes, best mode examples. Add a branch to a tree with label vi and subtree and return it. So there are issues by using decision tree learning. Let's see what are those issues. How deep the tree grows. So it is an issue where there has to be making decisions at each and every step, which might grow the tree into a very long and huge model. Handling continuous attributes. There is an issue where handling continuous attributes, which is a problem during a decision tree. Using an appropriate attribute selection measure. This depends on the model we have been created. If the training data are not proper, then the choosing the appropriate attribute would be a problematic. Handling training data with missing attribute values. So the data sets usually does not would be not always a great data set or an uh, complete data set. There would be missing values. So how do we handle the decision tree learning algorithm when there is missing values in a training data? These are the issues. So overfitting in a decision tree. If a decision tree is fully grown, it may lose some generalized capability. This phenomenon is known as overfitting. A hypothesis overfits the training example if some other hypothesis that fits the training example well, less well actually performs better over the entire distribution of instance, that is including instance and beyond training examples. This is known as an overfitting. Causes of overfitting. Overfitting due to presence of noise. Mislabeled instance may contradict the class labels of other similar records. Overfitting due to lack of representatives instances. Lack of representative instances in the training data can prevent refinement of learning algorithm. This is an example of overfitting due to noise, where classification of mammals has been done and asterisk denotes mislabelings, where here in class label the third one bat has been mislabeled and the fourth one whale has been mislabeled. So these are the errors due to noise which causes a overfitting in the model. This is another example for overfitting due to noise, which is set of classifying mammals where the mammals have been class labeled have been miscalculated. Overfitting due to lack of samples. Although the model's training error is zero, its error rate to the test set is 30%. Humans, elephants, and dolphins are misclassified because the decision tree classifies all warm-blooded vertebrates that do not hibernate as non-mammals. So here, the miscalculation has been done here. Avoiding overfitting in a decision tree. Approaches the stop growing in the tree earlier before it reaches a point where it perfectly classifies the training data. Approaches that allows the tree to overfit the data and then post tune the data or the tree. So this is a brief explanation of the topic decision tree algorithm. Hope you liked it. Please like, share, subscribe. Thank you.